All right, our next presenter today is Nghi Wei on the topic clone detection in programming language. Please welcome.
Thank you, Chair. So I will give you a motivating example to define what is code clones in programming language. So suppose that we have these two functions like this. Then in each function, we define some variable. The above one, which is the set, the second one, which is the map. Both of them are data structure to contain some information. And then we iterate over these two structures to bring all of the information of that data structure into the screen. So although that the variable is different, but the logic is the same, so we call it clones in programming language. So what's the problem with code clone? If we create code plots, we create cognitive load of future maintainers. Turn back to the original example. Suppose that if you have thousands of clone pairs in the system like this, and when you want to change something, you have to find another 1,000 pairs, and you have to change it manually. That's very painful. So what is problem? It's very hard. Think about an analogy. Suppose that you are given a lot of books like this, and you are asked to define similar text segment among all of these books. So you don't know where to begin. So you have to begin from one book and compare that book to all of the others, right? So this is very painful also. So this problem is very similar to the plagiarism detection in natural language. So the first problem of code clone is that how to match clone pair, which is maybe the text, maybe exactly string matching of clones, or it's just a patchwork matching, just like plagiarism detection. The second problem is that how can we find all clone pairs among all possible pairs of segments? So in this presentation, I will just focus on the technique to match clone pair, and I will not give any information about the other problem. So there are three approaches. I will go with the first one, which is the text matching. In text matching, we represent and evaluate code using text comparison. For example, we have these two examples. The first one, the variable is A, B, C, and the second one is the B, C, A. So they seems very similar, but the variable is different. If we use text string matching, match exactly word by word, text by text, then we get the result non-clone. But it's supposed to be clone. So this approach will give high risk of false positive. So to overcome this problem, we move to the token string matching approach. In this approach, we tokenize everything except the language construct. For example, we have these two pieces of code like this. This is supposed to be cloned. But if we use text matching, so it yields the non-clone result. For this approach, we tokenize every token to a fixed character except the highlight part, which is the language construct, and then we match these two pieces of code together. We move to the last one, which is the tree or graph matching. Suppose that we have two examples like this. If we use the token string matching, we tokenize everything. Oh, sorry. We tokenize everything. Then, if we match these two things, it will result non-clone. So there's a problem with token string matching. So return to the original example. First, we need to convert source code into tree graph representation, just like this, which is the tree representation of the source code. And the next step, we convert the tree or graph to vector using some pattern mining algorithm. So this is the vector. And then we calculate the vector similarity. For example, we use cosine similarity to compare these two vectors. For the performance comparison between these three, we can see that we manually collecting data from open source project, approximately 10,000 clone pair for validation. For the precision and recall, we can see that the text matching yield highest result. In conclusion, with text matching, it's older and it's studied extensively already. And it is complex and its syntax provides syntactic understanding, while in the graph matching, it's newer, leading edge, and more complex, and provides semantic understanding. While token string matching, which is stand in the middle, not very old, but not very new, and provide both syntactic understanding and semantic understanding and synthetic understanding. So that's all for my presentation. Thank you. You have any question?
How efficient can you get in terms of clone detection? In a piece of code, how much clones are there? Can you expect to find in a piece of code? Does that depend on the style of the coder?
It depends on the approach that we are using. So there are three approaches. So if we use text matching, we can use not very good result. If we use graph matching or tree matching, we can use some good enough.
What is the percentage of code clones you expect to find in a piece of code?
So your question is that what is the precision of the code clone when we apply some technique into real code?
No, not the precision. The quantity of clones that you expect to find through the best method.
I think I think it also depends on the data set we use. So for different programming language, the style is different. Then we apply, for example, the best technique, which is the graph matching, we can get different result, and it depends. There's no fixed result for the number of clones that we can find. Is that answer your question?
I know, but why do a method? Why do a method like this, which is quite complex, but to actually do clone detection? I mean, your purpose of clone detection is what? Is to tighten up the code and have better code in the end, right?
Yes.
So my question to you is that how many clones you expect to find in a large piece of code?
So you mean large piece of code? In your meaning is that we need to have the size.
40,000 lines of code or 50,000 lines of code, right?
Okay, so suppose that you are talking about 50,000 lines of code. So then, based on the performance comparison, you can see that the precision of the tree matching it should be around 80%, which is you can find out approximately 40,000 clones over 15,000 clones per of code. Is it?
You mean?
So.
Okay. Does somebody understand? Or?
Actually, I'm not quite sure that he understands your question.
No,
I
mean,
think your question.
Approximately clone pairs for validation, right?
Yeah,
so
clone pairs.
You must first identify the clone pairs.
Yes,
right?
yes.
And so not every piece of code has many clones, right?
Okay, yeah.
So that will depend on the code.
Yes.
Okay. So my question to you is that how many pairs of code do you expect in a significant piece of code like 60,000 instructions?
Okay. So I think your question related to this part. So for the part to find or to identify the own clone pair among or poster pair of segment, because I did say that I will not, because this presentation will focus more on the matching the clone pair. We suppose that we already have the clone pair
You
ready.
already have the clone.
Yeah, yeah.
Okay. All right, okay, no problem.
Any other question?
So which method is more sensitive? Because you mentioned that.
Okay.
Okay, so my question is, which method would be more sensitive? Because you mentioned that not all the code has to be coded the same way to be detected, right?
Sorry, can you?
The sensitivity of the application, which one will be able to detect more clone pairs? They are not necessarily coded in the same way, but they are similar, but they're not identical.
So your question is that if different developer code it in different way,
Mhm.
so can we detect the clone pair? So yeah, it can.
Okay, which one is better out of the three?
So the three matching always the best one among the two other. You asked about the technique, right? Which
Yeah.
technique work best among
In
the
terms
other,
of
right?
in terms of the sensitivity, and I think you mentioned the percentage, right? How much you can capture.
The percentage? I think because I didn't mention anything about it, but the percentage here is that we already have the clone pair ready. We suppose that we already know the clone pair,
Mhm.
and we validate over with our technique. I didn't mention any technique about how to find the clone pair. We suppose that we have the clone pair ready in this presentation.
Okay.
May I have a question? Okay, so
So you did mention that the graph matching is very good method, right? Good approach compared to the other two approach,
Yeah.
token string matching and the text matching, right? So, but I wonder if you just have the simple code, you do not have a very complex code. So will graph matching, yeah, can still get a good performance?
Okay, so your question is that you want to ask if we have just only small code.
Yes, small and simple.
Small, in the case of small and simple code, we don't need this technique. You can simply control find the similar things in your code base because it's very small. Do not bother to.
Yeah,
to
but
use
the
some
thing is
complex.
that even though in the simple code, it still consider the structure of the code, right?
Yeah, exactly.
So in this case, graph matching can still useful.
Yeah, it is useful.
So in case that it still somehow get a better performance compared to the text matching, right?
Yeah, because yeah, as I say, we already have the pairs. I forgot to mention about the size of the pair. So this pair of data set contain a lot of size of matching clone, which is a lot from small size to big size. So it will yield a precision around 80%. So you okay? So you see the benchmark comparison here. So among 10,000 clone pairs validation, you can see the pair will be in different size.
In different sides.
So we do evaluation on different size of code.
But this one is because you just use one software project, right?
No, many software projects. I mentioned projects, not project. Projects.
So how many?
S,
Actually, how many process that you have done so far?
around 10 projects.
10 process
Yeah.
and 10,000 clone pairs.
Yeah.
Okay.
I have one question.
Final question.
Yeah. What is the drawback of tree, according to you, tree-based? Is there any drawback, or it solves all the problem, tree matching?
So the drawback is that we need to choose that.
Oh, so your question is that if the tree matching has some drawback? So the tree matching actually has one drawback is that it needs to convert the tree to the vectors because it needs to do one step converting. So the performance, if we do on large scale, we need to wait a very long time to find all the clones in the system.
It is not applicable for large.
It's
code
applicable, but
But if
it's not real time. It's not real time.
If it takes too much time, then it's creating a performance overhead, so it will kill the purpose of doing it. isn't
Okay.
it?
That makes sense, but normally when you want to reduce the code block in your source code, you just do it one time. For example, you have a project, then you just do analysis by using tree graph matching, and whatever time you will wait, you just do it one time. Then you identify all the clone pair. Then you do refactoring, just one time. Although the first time you analyze the system will take a long time, but you need to do it only one time.
If it's the project I have a different project, I want to detect clone.
Yeah, you have to do it again.
So, but it's not one time, it's going to be doing it. many
Because
times.
Because normally a developer just do it, just work only for one project. You never work on more than 2 projects together at the same time,
so
right?
do you think that it is practically applicable?
Yeah, it's applicable.
Yes.
Applicable in terms of
Serial.
I think not very serial, just 2 consecutive questions from one person.
3.
3, not 3. Yeah. Because if I see he asks for the 4th question, then I will stop him.
Normally it's 3, yeah, normally
Is
it's
a
3.
serial killer. When the
But-
question is what they're interested,
Yeah, exactly.
which is a big danger,
Yeah.
because all of us will switch off.
Yeah.
Only the 2 of you are talking.
But actually, could there be a situation where like a person, a serial killer actually represents the question that everybody else wants to ask? Especially
Yeah, but then
like
if that question is not, you will not know that question because it will be cut before the 3rd one, right? But very often, you remember that when you hear a question, if you're not interested in that question, if intellectual that question is interesting, stimulating, it becomes your question.
Yeah.
So it's very rare that people ask questions that are of no interest to the audience, because somehow that question will become interesting.
And no matter what, even if that same person is asking a question that everybody is interested, but you realize this tendency, you only stick to the person who asked the question. You don't include the rest. And once you don't do that, somehow by body language, we think he's just addressing him.
Yeah.
Yeah.
So I asked a question, I'm sorry, I forgot to, because I was looking for the motivation, right?
Yeah.
But then you said, I forgot to mention that. We're only going to do that, and so my question was on the next one, of course.
Yeah.
Which is more interesting. It's, yeah. Maybe you should have said so quite earlier on, because you can, I spent quite a long time trying to get to there, and then.
Yeah, maybe I should.
You should have cut
Yeah.
me off and said, I understand, you want to know, but in this presentation, to keep it to 2 sides, we're only focusing on this particular point.
Okay.
That's it.
Yeah.
I wasted your time. So repeat the question, avoid the serial killer, deal with me a little bit differently so that you can save time also in the question. So there's still a few problems at the question level. Be careful, it looks as though you're very, I liked your attitude. When somebody was asking a question, you actually tried to understand, and we could see you were trying to actually feel what exactly is the question behind. So that's good. That means good listening skills, and At the same time, it's careful. It's a Q&A where everybody can have questions.
Okay.
Okay.
Yeah.
All right, the science.
Is the mic?
I know this is not your field at all. Right?
It is very difficult. Yeah. Honestly, I feel that
Put the title slide again. Yeah, clone detection. Oh, I think we
You're
moved
not in
the.
slideshow. Yeah, you're not in slideshow.
I think the cable may have moved when you pushed the. But move the cable a little bit. No. Yeah, it's a cable issue. Okay. Yeah. Okay. Clone detection in programming language.
I think the title was quite clear to me. Like I have an expectation of the code that you're going to talk about and how you're going to match the pair and so on. I like the example that you bring, like the books, the library. That's something that non-experts would be familiar with. It would be good if you could insert a bit more of the story when you talk about the matching, like how it relates to the books example, or like plagiarism checker, something like that. So I think I would agree more if you could talk about the mechanism of how the token actually works and spend more time on the slide on performance comparison. I think that's quite an important slide. So instead of just going past, because I saw that there's precision and recall. So precision was the point that I didn't get it the first time, but then after your explanation, it became clearer.
Okay. The next one. So what are you commenting on?
Me is the person,
The host.
the host. So actually for the eye contact, so mostly I just see that you look at this side, not this side. I don't know, and especially I see that you never look at me, the other side here. Yeah, you usually take a look at your slides. So to me, it feels that the slides is more important.
Yeah. A lot of eye contact with the slide.
Yeah.
Absolutely. A lot.
I really like your hands like this. When you say something, your hand is just open the problems. Yeah, I really like it. And but I'm not quite sure because you moving forward and backward too much. Actually, I'm not really understand why you keep moving. Yeah.
So again, but same. I think it was you, right? You were moving.
This guy.
You were moving backward and forward. Okay.
Yeah.
So the different. Yeah.
And the thing is that after the conclusions, when you say about the Q&A, so you just a little bit moving backward instead of moving forward, like her. When at the end of the conclusions, she's moving forward, but you're moving backward a little bit.
That's
Yeah.
the body language to say I'm not comfortable taking questions, right? So
Yeah,
you
yeah.
betray your lack of comfort by moving backward.
Yep. Okay.
Slides.
Slides,
I think animation was good, slides were good, like all balanced, left and right. And transition was, I feel like it was good transition. You didn't show it all at once. You take your time and you create an expectation. So to me, it was good. But
You mean when you talked about the 3 methods, right?
3 methods, even all his slides were like step by step, which is good, like for understanding. If you put a plot all at the same time, then it is difficult to understand. So, which is a good point. Can you go to the tree slides, the 3 structured slides? Yeah. Yeah, here, go back. I think you missed a link or something, copyright.
You go back.
No, for this image.
Yeah, there's a link for the image.
The issue I had.
Did you take it yourself?
Did you paint it
Did you take
yourself?
that photo yourself?
Yeah, I take this photo in the library.
My own library. You did?
Yeah, take this photo in the old library in my own university.
Okay. All right.
Okay, then can you go back to tree structured? There is a diagram of tree. No, next. It's a slide. No, go forward. Yeah, here, that less than equals to sign, it's not so clear. You can put a circle. If you say tree, then usually we see it as a circle in all the nodes. So yeah, you can put a circle. Within that circle, you can put all your content, which would look more intuitive, I guess. Because that less than sign was not so, it doesn't look good to me. And can you go to the graph? Yeah. So I find it's a bit small, the font size. Can increase a little bit the font size
Yeah.
of the graph, and you don't have a label on y-axis. Even though I can say that it's performance comparison, but still technically I think you should have a y label. I'm not sure.
Because originally I assumed that everyone know about the precision and reform because this is very basic.
No, label, y-axis. Yeah, on y-axis. You don't have label. Yeah, that's all.
All right. And the high moments?
Yay, it's my turn. Sorry, but I think you missed me.
Yeah, you miss me too.
The way you introduce to the problems, I think is quite counterintuitive. So you introduce from a technical approach, and then you try to find an analogy to make people understand it better. Now, but in my case, I'm struggling with understand the technical things that you introduced the first hand. Therefore, I think I missed the analogy.
Yeah.
So it would be better if you introduce the library stuff before, and then you try to map the technical things.
It's never a good idea to start with background. You started with background and explaining what a clone was. It's not a good idea. You start with the metaphor, you start with the problem, and then later on you move into more specific into code. I think that's totally agree with you.
And since you have a monotonic tone, then I don't feel anything. And at the conclusions, I think you rushed because you were running out of time. Therefore, you didn't come back to the analogy. So you didn't answer the questions.
Yeah, you did not finish the talk. Yeah. You were about 30 seconds late.
So that's all for me.
Okay. All right, so again, control of time for you. Maybe you had a little bit too much to explain. You had the 3 methods and then you had a lot of clicks. So notice that when you have a presentation which has many clicks, what happens? When you have a presentation with many clicks for 5 minutes, what happens?
Click some.
Huh? No, I mean, it happens, so, did you notice? It affects the host, right? How does it affect the host?
Look back and forth.
He's constantly looking at the screen, because click, 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 right? So the screen becomes his, everything, you know, look at the screen, everything's gonna happen at the screen, don't look at me. My whole story is on the screen. So you pretty much lose it as a host, and you become a clicker. Okay? That's the problem with too many clicks. So yes, it in a sense it helps to understand because you lay out a little bit at a time and things like this. But then, the drawback of that is that as a host you lose it. So you have to find a balance between explaining for clarity and then reducing the amount of material actually, so to really focus on the essential. It's the only way that you get that balance. Huh? But right now the balance was towards the screen, huh? So you lost it as a host. Okay? All right. Okay, so thank you.
Final one.